Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. The vibrational energy of carbon monoxide is 0.2691 electron volt when the constituents of the molecule are the most abundant isotopes of carbon. M equal to 12.00 U, that is atomic mass unit, and oxygen M equal to 16.00 U, that is atomic mass unit. Part A of this problem is what would be the vibrational energy if the oxygen were replaced by the less abundant isotope with M equal to 18.00 U, that is atomic mass unit. Okay, M equal to 12, M equal to 14, and then M equal to 18. The next possible value of M is 14, and that is it, that will appear in part B. Okay, part A is what would be the vibrational energy if the oxygen were replaced by the less abundant isotope with M equal to 12.00 U, atomic mass unit. Part B, what would be the vibrational energy if the carbon in the original carbon monoxide were replaced with radioactive carbon used in radiocarbon dating with mass 14.00 U. Okay, dear students, here M equal to 12, M equal to 14, M equal to 16, and M equal to 18 are all used in this problem, and we have to calculate or find out the vibrational energy. Okay, in this problem we are dealing with vibrational energy. In some other subsequent problem we may deal with rotational energy. Okay, anyhow, we keep ourselves restricted only to vibrational energy in this problem. Okay, the vibrational energy of carbon monoxide is 0.2691 electron volt when the constituents of the molecule are the most abundant meaning available in excess, maximum availability. Okay, abundant isotopes of carbon M equal to 12.00 U and oxygen M equal to 16.00 U. Part A, what would be the vibrational energy if the oxygen were replaced by the less abundant isotope with M equal to 18.00 U. Part B, what would be the vibrational energy if the carbon in the original carbon monoxide were replaced with radioactive carbon used in radiocarbon dating with mass equal to 14.00 U. Okay, dear students, we are going to solve this problem in a slightly different manner. Okay, but despite this different methodology, we will reach the same conclusion, same result. There will be no difference. Okay, whether we follow the traditional methodology or a methodology somewhat different from the traditional methodology. Okay, Dear students, here vibrational energy of carbon monoxide is given. So here there are two ways to solve this problem. One way is that we keep vibrational energy as this and solve the problem. The other way is that we first move to helping tool number 3. Okay, this is helping tool number 3. Table 10.1, second last row, carbon monoxide CO. Okay, frequency and then force constant, Newton per meter, 1860 Newton per meter. This is our tool number 3. Okay, or meaning in the next step we have taken other version of this helping tool. Okay, we see other version or this. Okay, so dear students, here table is 10.1, that is first table of 10th chapter, while in its alternate version, having been taken from some other book, table is 11.2, that is table number 2 of chapter 11th. Okay, second last, carbon monoxide 1860. Okay, so dear students, these tables of physical constants are given in every book of physics. Okay, sometimes these tables appear in between the chapter at relevant places, and in some other books these tables are included in appendix at the end of the chapter. Okay, so irrespective of whether such tables appear in between the chapter or these tables appear in appendix at the end of the chapter, we have free access to these tables. Okay, so one way of solving this problem is that we utilize this value which is given in this statement. Okay, vibrational energy of carbon monoxide is 0.2691 electron volt. The second methodology is that we do not take that value to solve this problem, rather we take this value. Okay, 1860 force constant K, carbon monoxide, frequency is 6.42 into 10 raised to the power 15. Okay, force constant Newton per meter 1860. Okay, so dear students, in this problem we have taken this value. Okay, force constant 1860 Newton per meter. Okay, what we have done, we have decided to avail this facility. Okay, facility having been provided through table of physical constants. Okay, and in response to this, the facility provided in the statement, which is 0.2691 electron volt, is not being utilized. Okay, dear students, it is our discretion whether we avail this facility or we use availability or we use facility provided through table of physical constants. Okay, so dear students, we have gone through helping tool number 3. So now we go through helping tool number 1 and helping tool number 2. Okay, helping tool number 1, reduced mass of a diatomic molecule, Mr, where R is written as a subscript of M. Okay, M R having been written as a subscript of M stands for reduced mass. Reduced mass of a diatomic molecule is equal to M1 into M2 divided by M1 plus M2. Okay, where M1 is mass of atom number 1 and M2 is mass of atom number 2. Okay, so dear students, reduced mass is equal to product of masses of two atoms in the numerator and addition of mass of these two atoms in the denominator. Okay, product or multiplication in the numerator and addition in the denominator. Dear students, this is helping tool number 2. This table has been used in our problems so many times. Okay, in this problem we see which quantities will be helpful for us. Okay, here dear students, Planck's constant H equal to 6.626 into 10 raised to the power minus 34 joule second, which is alternatively equal to 4.136 into 10 raised to the power minus 15 electron volt second. Okay, this value will be used. Okay, Planck's constant, this value will be used. Then dear students, 1 atomic mass unit is equal to 931.5 million electron volt over c square. Okay, this value will be used. Moreover, 1 electron volt is equal to 1.602 into 10 to power minus 19 joule. This value will be used. Okay, so how many values are going to be used in this problem are number 1 Planck's constant, number 1 atomic mass unit, and number 3 1 electron volt. Okay, these three values will be used. This tool, that is tool number 3, has been discussed already. Okay, now we come to its solution. Dear students, in the solution of this problem we are first going to develop some foundation, and this foundation will be used again and again in our upcoming videos, upcoming problems related to reduced mass and vibrational energy, rotational energy, etc. Okay, let us first calculate the reduced mass using the relation reduced mass mr, where r is written as a subscript of m, is equal to m1 m2 over m1 plus m2. That is product in the numerator and addition in the denominator of carbon monoxide made with C12 and O16 as m C12O16 equal to m C12MO16 divided by MC12 plus MO16. Okay, we have applied this formula MR is equal to M1 M2 over M1 plus M2 to this. Okay, so here same situation, multiplication in the numerator and addition in the denominator, and values of these two have been provided in the statement. Okay, so 12u into 16u. Okay, multiplication will come in a numerator and addition will become in denominator. So in the next step, when 12 will be multiplied with 16, then it will become 192u square. Okay, because 12u is going to be multiplied with 16u, so it will result 192u square divided by 16 plus 12 equal to 28. and hence in the denominator 28u. Okay, when we will solve this, one u will be cancelled from u, and instead of u square we will be left with only one u. And moreover, when 193 will be divided by 28, we will get 6.86 u. Okay, so it is the reduced mass. Okay, so one segment of this problem has been solved. Okay, let us now calculate. Now we move to a second segment of this problem. Okay, in second segment, sec Taha, hey, bolo na. Dear students, in this segment we are going to revise methodology introduced in a previous segment. Okay, let us now calculate the reduced mass using the relation reduced mass mr, where r is written as a subscript of m, is equal to multiplication in the numerator and addition in the denominator of carbon monoxide made with C12 and O18 as m carbon 12 oxygen 18 equal to mass of carbon 12 into mass of oxygen 18 divided by mass of carbon 12 plus mass of oxygen 18, and it will result in 12u into 18u divided by 12 plus 8. This will become equal to 216u square over 30u. One u will be cancelled. Okay, and hence we will be left with a single u. Okay, moreover 216 will be divided by 30 and we will get 7.2u. Okay, so two resulting values have been obtained. Okay, first value is 6.86u and second value is 7.2u. Okay, dear students, now we are going to define vibrational energy. We know that vibrational energy is given as E vib, that is vibration, where vibration is written as a subscript of E, is equal to h cut or h bar or h reduced into k over reduced mass mr, where r is written as a subscript of m. K is force constant. Dear students, h cut or h bar or h reduced is actually Planck's constant divided by 2 pi, and we know that pi is equal to 22 by 7, and we take its value up to 2 decimal places as 3.14. Otherwise, pi is a very special number. Its decimal representation goes endlessly. Its decimal representation is non-terminating and non-repeating. Okay, so in equation number 1 we will use k equal to 1860 Newton per meter, from where we have taken this value of force constant k. We have taken this value from tool number 3, in which a table was introduced into alternate forms or patterns or versions. Okay, force constant k is equal to 1860 Newton per meter. We have taken this value from the table which was included in tool number 3. Okay, and h cut is equal to 0.66 into 10 to power minus 15 electron volt over second. Dear students, for this purpose, in order to ensure that we have taken this correct value of h cut, we move to helping tool. Okay, helping tool, this is the helping tool. This is the helping tool. Here, dear students, h is given as 6.626 into 10 raised to the power minus 34 joule second, which is alternatively equal to 4.136 into 10 to power minus 15 electron volt second. This is the value of Planck's constant H. But in this problem we are going to use value of H cut, which is also called H bar, or which is also called H reduced. And we know that H cut or H bar or H reduced is equal to H divided by 2 pi. Okay, 2 pi means 2 into 3.14, that is 6.28. Okay, so here the purpose of going back to helping tool was just an attempt to develop some confidence that we are using correct value. Okay, value of force constant K equal to 1860 Newton per meter. This value has been taken from helping tool, in which a table has been shown in two different versions. Moreover, H cut or H bar or H reduced is equal to Planck's constant H divided by 2 pi, and hence its value is this. Okay, in equation number 1 we get. Okay, in equation number 1 we will put these two values, and then this modified equation will assume the shape as equation number 2. Okay, we get E Vib, that is vibrational energy, is equal to 0.66 into 10 to power minus 15 electron volt into second into 1860 Newton per meter. This is the value of force constant K divided by mr. Okay, here we have not yet put the value of mr. Okay, so using mr equal to 7.2 u and 7.47 u, 1 by 1 we get. Okay, dear students, mr appearing in equation number 2 has been calculated into two steps. Okay, one mr is equal to 7.2 u and other mr is 7.47. Okay, we once again show these two values. Okay, this is 7.2 u and this is 6.86 u. Okay, one time we will put this value and other time second time we will put this value 7.2 u. Okay, so here we have decided that using mr equal to 7.2 u and 7.47 u, 1 by 1 we get. Dear students, when we put mr equal to 7.2 u, then we have denoted this vibrational energy as E 7.2 u, where 7.2 u is written as a subscript of E. Okay, which is vibrational energy. Okay, vibrational energy where reduced mass is equal to 7.2 u, we have denoted vibrational energy as E 7.2 u, where 7.2 u has been written as a subscript of E, equal to this, which we have described above electron volt dot second into, here a value of K is force constant K is 1860 Newton per meter divided by 7.2 u. In the next step, this portion is exactly same as in the previous step. Moreover, in the denominator no change. However, in the numerator no change. However, in the denominator we have made a slight change. What slight change? We have used the value of u from our helping tool, in which a table has been shown, from where we are going to use 3 or 4 values in this problem. Okay, so here 7.2 is same as it is appearing here, but in place of u we have used its value as 931.5 million electron volt over c square. In the next step, this portion will remain unchanged while, dear students, this c square is in the denominator of the denominator, so it will be shifted as a numerator, okay, as a numerator, as upper portion of a numerator, and hence we will write it as 1816 Newton into c square, because c square is in the lower side of denominator, so it will be shifted above, okay, c square divided by, what we have done here, we have eliminated m, capital M, which stands for million or mega, that is 10 raised to the power 6. Okay, dear students, we have eliminated this m by doing, dear students, here we have equally shifted this million into values, okay. 7.2 has been changed to 7200, and moreover 931.5 has been reduced into 931,500 mass into electron volt, okay. We have put value of capital M, that is million or mega, and we have distributed it equally to these two values, okay. 1000 to this, where 7.2 has become 7200, and 1000 has been multiplied with this, and this figure has become 931,500 mass into electron volt. Dear students, in the next step, again this portion has not been disturbed or changed. However, 1860 into Newton into, what we have done, dear students, we have put the value of c square. C is the speed of light, and its value is also given in the same table from where we are using several values in this problem, okay. Speed of light c is equal to 2.998 into 10 to power 8 meter per second, but often instead of 2.998 we simply write as 3.0, okay. So value of speed of light c in shape of c square has taken the form as 9 into 10 to power 16 meter square per second square, okay. Because we have not used 2.998, we have used 3.00, okay. So 9 into 10 raised to the power 16, because speed of light c is equal to 3.0 into 10 raised to the power 8 meter per second, but here because c is in square, so in place of 10 raised to the power 8, we will get 10 raised to the power 16. And moreover, in place of meter per second, we will get meter square per second square, okay. The next step, once again, we have not disturbed this portion. However, we have just simplified this portion, okay. So here what will be done, dear students, here m square, here m, okay, meter square, here simple meter, okay. 1 m will be cancelled out and it will become simply m, meter, simply meter, okay. And dear students, actually a few steps back I have mistakenly understood this small m as a mass. It is not mass, it is meter, okay. So here, dear students, 1 meter will be cancelled out and we will be left with simply m. Moreover, dear students, this second square is in the lower part of a numerator, so and this is within the under root region. So this s square, when brought out of under root region, it will become simply s, and it will be in the denominator, and this s, that is this second will be cancelled out with this second square, because second square is within under root, and without under root it will appear as simply s, and these two s will be cancelled out with s. Okay, so in the next step again we no change in this portion, and we have just simplified this portion. Okay, so in the next step once again we have just simplified. There is no need to explain this simplifying steps. Okay, so this into this no rocket science, quite easy simplification. E 7.2 U has become equal to 0.6 into 10 to power minus 15 electron volt into this over this. Okay, next what we have done to this extent, no change. This, what is this 2495? Actually we have divided this quantity by this quantity. Okay, so it has taken the place as this Newton meter. This is electron volt. Okay, these two numerical values will be simplified as this value. Okay, and Newton meter is in the numerator and electron volt is in the denominator, and hence it will become Newton meter over electron volt. Okay, dear students, to this extent no change. Further, 157,986.52, what is, from where this figure has come? Actually, dear students, this value 2495974000, which is within the region of under root, when brought out of under root it will become this value. Okay, so what we can say, we can say that under root of this value is this value. Okay, moreover Newton meter is equal to joule. Okay, joule divided by electron volt. Here we have used the value of electron volt in term of joule from the same table in which several values are being used to solve this problem. Okay, dear students, here in place of electron volt we have used its alternate value, and hence from here joule will be cancelled out with joule, and we will be left with this portion. Next, no rocket science, just simplification. Then again just simplification, then again just simplification, and finally we have got the value of E 7.2 U equal to 0.2596 electron volt. Okay, this implies that E 7.2 U, where 7.2 U has been written as a subscript of capital E, has become equal to 0.2695 electron volt. Okay, so this is also a result of our problem. Okay, now we move to part B of this problem. Now let us calculate the reduced mass using the relation MR, where R is written as a subscript of M, equal to product in the numerator and addition in the denominator. Okay, MR equal to M1 M2 over M1 plus M2 of carbon monoxide made with carbon 14 and oxygen 16 as reduced mass carbon 14 oxygen 16 is equal to mass carbon 14 into mass of oxygen 16 divided by mass of carbon 14 plus mass of oxygen 16, using this formula. Okay, multiplication in the numerator and addition in the denominator, and here once again is 14u into 16u over 14u plus 16u, it will become 224u square over 30u. 1u will be cancelled out from u square, and we will be left with 7.47u. Okay, 7.47u. What we have done, said that using this. Okay, MR, this value we have discussed earlier, and this value we have calculated right now. Okay, anyhow we move forward, we do not go back. Okay, so value of E 7.2 U has become equal to this, and now we were dealing with part B of this problem, and hence here reduced mass has become equal to 7.47 U. Okay. Now, in the same way as we had calculated E 7.2 U, where 7.2 U had been written as a subscript of capital E, in this case we have written 7.47 U as a subscript of E is equal to, this is the H Planck, H cutter, H bar or H reduced, okay, that is Planck's constant H divided by 2 pi, this is the value of that thing, okay, into this is the value of force constant K, and this is the value of E, this is the value of reduced mass, okay, reduced mass of carbon monoxide made with the carbon 14 and oxygen 16, okay. So this 1816 Newton per meter divided Newton over meter into 7.47 U. In the next step, we have not disturbed these two values, okay. We have just used, we have just put the value of U, that is 931.5 million electron volt over C square in the next step, because C square is in the lower side of the denominator, so it will be shifted to the upper side of the numerator, okay. So C square has become here. Moreover, in the same steps we are going to repeat which we had taken in the previous part of this problem or video, okay. What we have done here, we have eliminated this capital M, which stands for million or mega, okay, and hence dear students, this million or mega, that is 10 raised to the power 6, has been equally contributed to these two quantities, that is, in place of 7.47 it has become 7470, and this value, that is 931.5, this value has become 931,500 meter electron volt, okay. So dear students, in the next step, just simplification. How simplification? We have used the value of speed of light c equal to 3.0 into 10 raised to the power 8 meter per second. So here, because speed of light is in square, so this 9 is a part of the value of c, which is 3.0 into 10 raised to the power 8 meter per second. So moreover, because speed of light is 2.998 or roughly 3.00 into 10 raised to the power 8 meter per second, and this c is in square, so 10 raised to the power 8 will become 10 raised to the power 16 meter square per second square. Dear students, here once again, this second square, which is in the lower part of the numerator, when s square is brought out of the under root atmosphere, under root region, then it will become simply s in the denominator, and this simply s will be cancelled with this s, that is electron volt second, okay. Moreover, 1 meter will be cancelled out from meter square, and we will be left with simply meter m in the numerator, okay. So this is the continuation of previous step, and this is the actually multiplication of these two quantities. Moreover, dear students, Newton meter over electron volt, next no change in this value, and Newton meter over electron volt, okay. We have just simplified these two values, and Newton meter over electron volt is in this form, okay. This implies that E, that is vibrational energy, 7.47 U is equal to 0.6 into 10 to the power minus 15 electron volt into 240 5758298 Newton meter into. What we have done? Newton meter over electron volt. Meter Newton meter Newton meter over electron volt. Here in place of electron volt we have put its value in terms of joule. We know that Newton meter is also joule, and this is joule inverse. Okay, because we have taken the value of electron volt in terms of joule. So here joule is power minus 1. Here Newton meter is also equal to joule. Here joule is plus 1, here joule is minus 1. So these two joules will be cancelled out, and hence after simplification we will get vibrational energy E 7.47 U equal to 0.25542 electron volt. And this is the end of our problem, and this is the end of our video. Till next video, Allah Hafiz.